So, good morning to all. I'm Subhashri from the Department of Computer Science, SNS City. Now, we are going to see about machine learning testing algorithms. So, first we have to learn about the difference between machine learning model evaluation and what is meant by testing. So, many practitioners may rely solely on machine learning model only based on its performance evaluation. However, evaluation is not the same as testing. So, it's important to identify the differences. So, machine learning model evaluations focuses on the overall performance of the model. Such evaluations can consist of performance metrics, curves, perhaps example of incorrect predictions. So, we have to follow the diagrammatic representation to understand it clearly. So, what is data set? So, data set has been further classified into training set, testing set, and validation set. From the training set and testing set, we have to be develop a model, and then the model which has been developed has to be in the form of an evaluation set. Okay, based on it, it has to be evaluated. The validation set will be used to evaluate the model. So the way of model evaluation is a great way to monitor your model's outcome between different versions. However, it does not tell us a lot about the reasons behind the failures and the specific model behaviors. For example, your model might suffer a performance drop in a critical data set while its overall performance doesn't change or even improves. Or in another case, model retraining on new data does not produce performance change but introduces unnoticed social bias towards a specific demographic group. So, to avoid such issues, you need to test your model to be able to narrow down the reasons and the mechanisms behind behavior change and track behavioral degradation for specific failure modes. So, here comes the goal of machine learning and its testing. So, software developers write code to produce deterministic behavior. Testing identifies explicitly which part of the code fails and provides a relatively coherent measure. The lines of code covered. It helps us in two ways. One is quality assurance, and the next one is identifying the defects. So, what does it mean by assuring the code? Whether the software works according to the customer requirements or not. We have to check whether it is a validation concept or not, identifying the defects and flaws during development and in the production stage. So, what here is to be developed is a model. However, in machine learning, a programmer usually inputs the data and the desired behavior. The logic is elaborated by the machine. So, here comes the machine is developed into a model first of all. This is especially true for deep learning. Therefore, the purpose of machine learning testing is first of all to ensure that this learned logic will remain consistent no matter how many changes we call the program. Okay, so how should model test be written? A testing model should be summarized based upon the thinking concept, that is, the testing set and then the training set. So, the test development has to be made first of all. When writing the model test, several issues need to be considered. For example, testing the basic logic of the model is mainly important here. So, while developing a model, we have to test the logic of that concept. Okay, managing the model performance by using manual testing. So, the model performance have to be measured in regular intervals so that the testing will be done in a very good quality. So, evaluating its accuracy, that means what accuracy we have to be evaluate? We have to evaluate the model's accuracy. So, that I have said already. Performance metrics is the sense of accuracy, timeliness. Make sure that the achieved loss is acceptable for your task. Checking the model's performance and real data is also a very good important thing. So, data scientists and machine learning engineers train models by feeding them with examples and setting parameters. The model training logic produces the behavior. This process raises the following challenges to testing machine learning models. So, here comes the lack of transparency, indeterminate modeling outcomes, generalizability, etc. Lack of transparency in the sense many models work like black boxes. Indeterminate model outcomes means models rely on stochastic algorithms and to produce the same model after training. Here already the model has been trained. So here we are doing the retraining. So what is mean by generalizability? Models need to work consistently in different circumstances other than their training environment. Even though if the model is to be model put into a different new environment also, it should give a proper output. That is the main concept of generalizability. So there is an unclear idea of coverage. There is no established way to express testing coverage for machine learning models. Coverage does not refer to lines of code in machine learning as it does in software development. Instead, it might relate to ideas like input data and model output distribution, etc. So, what is the resource need? Continuous testing of machine learning models is resource and time intensive. So, the resource identification is very important while used for the testing. So these issues make it difficult to understand reasons behind a model's low performance. So the interruption of the results will be held, and the data assurance will also be not correct. So there is a change in the input data distribution, that is a data drift. If there is any change in the data, we can call it as a data drift, or in the relationship between our input and output variables. If there is a change in the data, we will call it as data drift. While there is a change between the input and the output variables, we call that as a concept drift. There is a difference between data drift and concept drift. So the principles and best practices in machine learning model testing is done. It is not very much easy, and testing machine learning models is even harder too. So you can prepare your workflow for unexpected events while working with dynamic inputs, black box models, and shifting input or output relationships. That is based on the data and concept drifts. Okay. So for this reason, it is worth following established best practices in software testing. Test after introducing a new component, model, or data, and after model retraining. Test before deployment and production. Write tests to avoid recognized bugs in the future. Bugs here includes the errors, okay, while training the model. However, testing machine learning models have additional requirements, such as you also need to follow testing principles which are specific to machine learning problems, such as robustness, interpretability, reproducibility, etc. So let's see in the next video. Thank you.